Hi, Assalamualaikum. My name is Puteri Shaerra. This is our group members. First is Nanthini. The second one is me, Puteri Shaerra. The third is Syahidah, Aqila, and the last one is Sham, Afifah, Amirah. Here in this video, we will explain about two types of sequence, which is arithmetic sequence and geometric sequence. It includes all the theory and formula for both sequence, and we will also explain about two problems of arithmetic and geometric progression. Before I explain about arithmetic sequence, let me explain about the meaning of sequence. Sequence is a set of numbers in particular order, with each number in the sequence being derived from the particular rule. Now let's proceed with the arithmetic sequence. An arithmetic sequence is a list of numbers with a definite pattern. If you take any number in the sequence, then subtract it by the previous one, and the result is always the same or constant, then it is an arithmetic sequence. As can we see in the picture, common difference can be positive and also negative. As you can see in the positive, A is 5 and the common difference is 4. And in the negative, A is 20 and the common difference is negative D. We can see that the first term is A and the second term is A plus D, when D is a common difference for the sequence, which can be obtained by subtracting any term from the term which immediately follow it. 4, 4, 4, negative 3, negative 3, negative 3. That means it's a following. We can conclude that it means the sequence can be positive or negative or even zero. Last but not least, I will explain about the formula of arithmetic sequence. The first formula is to find n sum, which is in this picture. You can see that an, or we can call Tn, is equal to A plus n minus 1 multiplied by D, which is Tn is the nth term, A is the first term, D is the common difference which can be determined by Tn minus 1, and n is the number of terms. We can see in the example in this picture, find the 46th term of the arithmetic sequence. A is 3, the common difference D is 5. To find the 46th term, we can use the formula that I said previously. Tn minus T46 equal 3 plus 46 minus 1, and the common difference is 5. And the next step is 3 plus 45, which is 46 minus 1, so it's 45, and multiply 5, and the answer is 228. The second formula of arithmetic sequence is to find sum of first and term. We can see in this picture, which is Sn equal n over 2 multiplied by 2a plus with n minus 1 multiplied by d, or we can also use Sn equal to n over 2 and multiply a plus l. Sn is the sum of first term, n is number of term, a is the first term, while l is the last term. We can see the example in this picture. We use the sum formula, which, for example, 5 over 2 multiply 2a, a is 1, plus n minus 1, 5 minus 1, and multiply d, d is 1, which you can get 5 over 2 multiply 2 plus 4, and the answer is 5 multiply 3, which is 15. The last answer is 15. So that's all for me. So next, Nanthini will explain two problems of arithmetic sequence. Thank you, madam.
Thank you so much, Shaerra. So now I'm going to explain how to solve two problems in arithmetic sequences. Two problem of arithmetic. So the first question is calculate the sum of all the even numbers from 2 to 100 inclusive. As we can see here, this is the arithmetic series. So the first thing that we have to do is identify nth term. How to identify nth term? By using this formula. So what we have to do is this. Okay, I just using this formula. I put 100 first because they said nth term. So our nth term, which is the last term, 100, and then they say that first term, our first term for this number is 2. That's the reason why I put 2, and then in bracket n negative 1 and times with 2. This 2 is actually the common difference. How am I get the common difference? It's actually simple. For negative 2. For negative 2 means we will get 2. That's the common difference. So after we finish that, we can multiply this, we can times with this. So after we times, we will get this, and then the last answer will be 50. How am I get 50? Because 2 negative 2 means 0. So 100 divided by 2 means 50. So we already get n term. After we get n term, it's actually easy to do the sum question. So as you can see here, this is the formula that I'm using to do this question. So the first is Sn. So we already, as madam can see here, I already stated that n equals to 50. So S50. So here we can see that n equals to 2. So we already know that our n is 50. So just put that 50 divided by 2 in bracket a1 plus an. So our a1, which is the first term, our first term is 2, and then our last term is 100. I just put here, and then what we have to do is this equation we have to settle first. Then only we can divide. So if we settle this, we will get 102. So 50 divided by 2 times with 102. So we will get 2550. This is the answer for the first question. Let's move on to the second question. This question is, in the arithmetic series, which is this, k is a positive integer and k is a factor of 100. Find in term of k an expression for the number of term in this series. So now I'm going to use this formula to calculate the answer for the question. All right. It's actually quite easy because I already mentioned previously how to do the question. So we just need to transfer only. As you can see here, n term, as I said before this, the last term we have to put in front. So our last term is 100. I put 100 in front, and then k, the first term, our first term is k plus n negative 1 times with k. Our common difference is k, so we just put k at there. And then if we multiply this nk, we will get nk. If we negative 1 times with k means we will get negative k. So if we do that, we will get clearly we can see here what we can cut from here means k negative k means it will be 0. So we can cut this. So definitely we will get that 100 divided by k, because we move this n in front because that's the n term. This is the answer for the n term. So we already get the answer for the k. It's quite easy. That's the reason we have to follow the equation, the formula. So let's move on the next questions to find in term of k the fifth term of an arithmetic sequences. As we can see here, this is the first term, second term, and third term. So what we have to do is we have to follow the formula. So the first thing that we have to do is, all right, we have to identify the common difference between these numbers. So if we get the common difference, then only we can identify the fifth term. All right, the first thing that we have to do is, they are already given the three numbers. So I just choose 4k plus 4 here, and then I just minus with 2k plus 1. Either I choose actually 2k plus 1. If can also another way also have, which is 4k plus 4 minus with 6k plus 7, because we identify the common difference. If we using the both numbers also, we will get the same answer, which is 2k plus 3. All right, after we identify the common difference, which is 2k plus 3, it's very easy to identify the fifth term. So in this fifth term, they already mentioned the fifth term, so we put in front the fifth term, and then we just follow the formula, which is 2k. I put 2k plus 1 because that's the first term, and then plus with 49. Why am I put 49? Because n negative 1, our n is 50 negative 1, 49. So, and then the last is the common difference. Our common difference is 2k plus 3. So if we calculate this, we will get like this, and then the last answer we will get 100k plus 148. Why am I get this? Because 2k plus with 98k means 100k, plus with 1 plus 147 means 148. So this is the last answer for this question. Let's move on to the second questions. So this question is asked, the first term of arithmetic sequences is 30 and the common difference is negative 1.5. The value of the 25th term, they asked to find us the value of the 25th term. So how to do this? Actually, it's quite easy to, because we just following the question, the formula. So I just put 25th term in front, and then 30, because they already mentioned that 30 is the first term, plus with 25th over the n, negative 1, and then the last term is negative 1.5. So if we calculate this, we will get 30 negative 36. So the real answer is negative 6. It's actually quite simple questions. And the last is, all right, we can see here, the R term is the sequences of 0. Find the value of R. How to find the value of R? Okay, to find the value of R, they are already actually given the first term is 30, the common difference is negative 1.5. So we just using the formula, the first term, which is 30 plus R negative 1, and then the last term is negative 1.5. So we just multiply this R negative 1 times with negative 1.5. So we will get this equation, this number. And then if we multiply this, we will get 31.5 equals to 1.5 R, because we just move this negative 1 R in front. So it the negative will be gone. So it will be like positive. So if we multiply this, which is 31.5 divided by 1.5, so the answer will be 21. So I hope that this is the easy equations, and easy equation to understand about the arithmetic sequences. So thank you.
Hi, my name is Sham Amirah, and I'm going to explain about the geometric sequence. A geometric progression, or also known as geometric sequence, is an ordered list number in which each term after the first found by multiplying the previous one by fixed non-zero number called the common ratio R. The common ratio R can be obtained by dividing any term from the term which immediately follow it. It can be positive, negative, or zero.
To find the common ratio R equal to second term divided by first term or third term divided by second term. For example, given the following geometric sequence 2, 4, and 8, find the first terms and the common ratio. First term equal to A equal to 2 and common ratio R equal to 4 divided by 2 equal to 2, or R equal to 8 divided by 4 equal to 2. The formula for the general terms of a geometric sequence is T equal to A multiplied by R to the power of n minus 1. This sequence has a factor of 2 between each number. A is the first term, R is the common ratio, n is the number of terms. For example, find the fourth term. Fourth term is equal to 2 multiplied by 2 to the power of 4 minus 1 equal to 2 multiplied by 8 and equal to 16. Finally, summing a geometric series. A series is a sum of a sequence. We want to find the nth partial sums or the sums of the first n terms of the sequence. We will denote the nth partial sum as a Sn. The formula to find the sum of the first n terms is referring to our R value. If R value is greater than 1, Sn equal to A multiplied by R to the power of n minus 1 divided by R minus 1. If the R value is lower than 1, that means Sn equal to A multiplied by 1 minus R to the power of n divided by 1 minus R. For example, find the sums of the first 8 terms. To find the sums of the first 8 terms, S8 equal to 2 multiplied by 2 to the power of 8 minus 1 divided 2 minus 1 and equal to 510.
Next, I will pass to Syahidah Aqila to talk about the two problem of geometric sequence.
Hi, Assalamualaikum. My name is Syahidah Aqila Sabri and I will begin with geometric sequence problems. So here we go.
Okay, done. So the thing that I wrote here is actually problem 1. Sorry to listen tak lawa. Okay. Find the 80th term in a geometric sequence if the first term is 7 and the common ratio is 3. So for this question, dia dah siap bagi first term dia apa? First term dia is 7 and the common ratio is 3. This is very straightforward sebab dia dah siapkan, dia dah sediakan semua. Might be easy. So let's tengok jalan kerja pula. Jom. Okay, so I akan tulis dulu jawapan and I'll explain in details next video. Let's go. Time lapse.
based on the answer that I got, it's actually this one. Yay! I managed to get the answer for this one by myself. This is quite simple, I can say. So the first thing I did is 8 minus 1. Obviously, it's equals to 7. And I solved this one first, which is 3 power of 7, and I got 2187. And the last part I did was just times these two numbers, and I got 15309. The next one, time lapse. Okay, so for the second problem, as you can see, I wrote here, find the seventh term in a geometric sequence if a sub 2 is equals to 15 and a sub 5, this is 5 actually, equals to 405. Okay, so in this question, the common ratio is not given, so we gotta find one. Okay, so we can see the sub here is 2. Alamak, habis ingat. And the sub here is 5. Yeah, so we'll try to do it here. Okay, so what I did is I put the formula first, which is a sub 1, and then I put the r. We apply the 5 and 2, so 5 minus 1 and 2 minus 1, so it will be equal to, we'll just write them back on. 405 equals to a sub 1 r4, 15 a sub 1 r1, and then just subtract 4 from 1, it's r3, and 405, 15. How do I get 257? Is actually the quotient. 405 out of the quotient of 15 is, we got this 257. Now to cancel the 3r is actually we have to square root both sides, and the answer we will get 3 equals to r. So obviously we have done for the first phase here. Now I bring down the second term, which is 15 a sub 1, 3, 2 minus 1. So after we evaluate that, we will get 15 a sub 1 times 3. So now we isolate the a sub 1, we will have to divide 3 in both sides. And the answer that I got down here is 5a sub 1. So this is like the last part of everything. So now we already got the a sub 1 is equals to 5 and the common ratio r equals to 3. So now all we got to do is just to apply the formula as usual, which is a sub equals to a sub 1 r and minus 1. This is the formula. And now we just apply a sub 7. Why a sub 7? Is because it is the seventh term. Okay, so a sub 7, 5, 3, 7 minus 1. This is the common ratio. Okay, so let's just proceed. So 7 minus 1 is equals to 6, obviously, and 5, 3 power of 6 will get 7 to 9, and we will get the final answer, which is a sub 7 is equals to 3645. Okay, so there it is, two problems for the geometric sequence. I hope you guys do enjoy the video, and I'm sorry if there's any lacking in any parts of the video. I'm really sorry. I'm trying so hard to actually venture this by myself, and I'm glad I did this. So massive thank you to everyone, and hope you enjoy, and until we meet again, see ya. Assalamualaikum.
No, 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 no.